solve exercise problems now. Exercise 10.2. I haven't solved exercise 10.1. That is because I've taught you the concept. You can go through the textbook and you can find out the answers by yourself. Exercise 10.2, question number 1. I'll read the question for you. From a point Q, the length of the tangent to the circle is 24. Now there is a circle here. From point Q, the length of the tangent to the circle is given. So I can draw the tangent on this side or on the other side. You can draw it on any side that you want. From a point Q, the length of the tangent to the circle is given as 24 centimeters, and distance of Q from the center is 25. Distance of Q from the center is 25 centimeters. It's 25 centimeters. And I've said before, the length of the tangent is 24 centimeters. Now you have to find out the radius of the circle. Radius R is the question mark. Let me indicate this point by T and this point by O. I know from the theorem 10.1 that when a line is drawn from center onto the tangent, that line will be perpendicular to the tangent. So this is right angle. This is 90 degrees from the theorem 10.1. So I'll write solution from theorem OTP is at right angle. So OTP is equal to 90 degrees. OTP is 90 degrees. So when this is at right angles, so isn't it a right angle triangle? I'll simplify this diagram. This is going to look something like this when you draw separately, where you have circle drawn here, somewhere here, like this, somewhere like that. I'm not going to draw that. So this is O, and this is going to be T, and this is going to be Q. This is at right angles. So what is at right angles? QTO. QTO. Okay. This is QTO. QTO is at right angles. So this is a right angle triangle, and the dimensions are given. QT is 24 centimeters, and OQ is 25 centimeters. Find out OT, because OT is equal to radius R. OT is equal to radius R. So if this is a right angle triangle, I apply Pythagorean theorem, that is hypotenuse square is sum of base square or the perpendicular base square plus perpendicular square. So therefore, from Pythagorean theorem, I'll just write PT, Pythagoras theorem. You have OQ square is equal to OT square plus QT square. OQ square is equal to, I know OQ, so let me just substitute the value of OQ. OQ is 25 centimeters. So this is 25 centimeters whole square is equal to OT square is 24 centimeters. It is 24 whole square, and not OT. So OT is unknown here, which is R. I'll substitute OT is R. R square plus QT is 24 centimeters. So 24 whole square. So 25 square is 625. From here, 25 square is 625, which is equal to R square plus 24 square is 576. 625 minus 576 is R square. R square is equal to, when you subtract So when you subtract 576 from 625, you should get 49. R is equal to square root of 49, and R is equal to root of 49 can be written as 7 square. The square root cancels, or this can be written in this fashion in much detail. And this is equal to 7. This cancels. R is equal to 7 centimeters. Question number 2. For the problem number 2, I am writing a diagram here and leaving the unnecessary details out, and just tell you everything that is required to solve this problem. This is a diagram. Point P, Q, and this is point, say P. Let me indicate this center as O. I am going to join these points, and this angle is given as 110 degrees. In the textbook, this angle is given as 110 degrees, and you are asked to find what is angle PTQ. What is angle PTQ is question mark. You might have learned in your lower classes that sum of all the angles in case of quadrilateral is 360 degrees. Sum of all the angles in case of a quadrilateral is 360 degrees. So let me write all the angles. Now this from the theorem 10.1 again, you know that this angle is right angle because this is center, O is the center, and a line is drawn to the point Q, which is on the tangent, and same here. Therefore this is also right angles, 90 degrees. So angle QTP or angle PTQ plus angle TQO, angle TQO plus angle QOP plus angle OPT is equal to 360 degrees. Angle PTQ is unknown, so let's keep this as it is. Angle TQO is 90 degrees plus angle QOP is given in your textbook, is 110 degrees plus angle OPT is again 90 degrees. This is equal to 360 degrees. Angle PTQ plus 90 plus 110 is 200 plus 90 is 290, which is equal to 360. 90 plus 110 is 180 degrees, 200 degrees, and plus 90 is 290. Angle PTQ is equal to 360 degrees minus 290 degrees. This, when you subtract, you should get 70 degrees. 70 degrees. There is another shortcut way to do this problem. Shortcut is in knowing some additional information, that angle QOP and angle QTP are supplementary angles, which means that, in easier words, sum of the angles QOP and QTP is 180 degrees. That is always sum of the angles, sum of the opposite angle. I'll just write it for you. Write it here for you. Sum of opposite angles in a quadrilateral is 180 degrees. So if this is 110, this is 110, then this should be 70 degrees. It's pretty simple. That is from theorem. This is a theorem, which we will probably be proving in our next class also. In the previous class, I was solving problems on circles from exercise 10.2. Today, this class is again continuation of exercise 10.2, and this is class 10 CBSE board syllabus. Problem number 4. I'll write the statement for the problem because the problem is in the form of theorem almost. So we have to prove that the tangents drawn at the end points of diameter, tangents drawn at the end points of the diameter are parallel. This is the problem statement, and we have to prove that the tangents drawn at the end points of a diameter are parallel. Let me draw a circle here. And I'll draw a diameter horizontally. Let me indicate the center by letter O, and there are two parallel tangents which are drawn at the end points. Since this forms the end point and this forms the end point, I have drawn two tangents or two lines. Let me indicate by letters, say x1 here and y1, and this as x2 and y2. I have to prove that they are parallel. To prove x1 y1 and x2 y2, line x1 y1 and x2 y2 are parallel. It is enough to prove that the alternate opposite angles here that you get are equal in magnitude. If you prove that, it is proved that x1 y1, x2 y2 are parallel. Let me take symbol P here, or letter P here, and Q here. Now since x1 y1 forms tangent at the point P, where P is point of contact, since this is a line dropped from center O. So therefore this angle is 90 degree from theorem 10.1. From theorem 10.1, this angle is 90 degrees. And this angle is also 90 degrees. Let me say this as Q, and this Q is point of contact. Just have explained in this case, here also you will have PQX2 as 90 degrees. So let me write the angles which are at right angles. Also this is also at right angles. So based on the same concept, you will have this angle as well as this angle as right angles. So therefore you have x1 PQ is equal to what? 90 degrees. x1 PQ as 90 degrees, and you have y1 PQ also as 90 degrees. y1 PQ 90 degrees. Similarly, in the right hand side you have x2 QP as 90 degrees. Again, y2 QP is 90 degrees. From theorem 10.1, I've written all these angles as 90 degrees. So this is 90 degrees. Y2 QP. So what did I have to prove? I have to prove x1 PQ. This is to prove that if alternate opposite angles are parallel, then these two lines x1 y1 x2 y2 will obviously be parallel. So I have to prove x1 PQ equal to x1 PQ equal to y2 QP. Y2 QP. I have to prove that, but these are the values I have. I can easily and straightforward can write that x1 PQ is equal to y2 QP, because let me indicate this equation, right? x1 PQ as 1 and this equation as 2, y2 PQ 2, equation 1 and equation 2. Since RHS of both equations 1 and 2 is 90 degrees, I can equate the left hand sides. So I am going to equate left hand sides. x1 PQ is equal to y2 PQ. This is y2 PQ. x1 PQ is equal to y2 PQ. Therefore lines x1 y1 and x2 y2 are parallel, hence proved. Hence you write the statement here that since these angles, alternate opposite angles are proved to be equal, so therefore x1 y1 and x2 y2 lines are parallel to each other. That's how we prove it. Just recapitulation of the problem again here. We have to prove that the lines drawn at the end points of the diameter on a circle are parallel. You learn from earlier classes in grade 8 or 9 or 7, wherever. You learned this like in your high school you probably learned that if there are two lines parallel, these two angles form alternate opposite angles. They will be equal only if and only if these two lines are parallel. If those two lines are parallel, we are actually using the same concept here again. If these two lines are parallel, then and only then these two angles, say A and B, will be equal. We are using the same concept here, but with only a small difference that the intersecting line is it is intersecting at right angles in this case. That is, this is the intersecting line, intersecting the two parallel lines at right angles from theorem 10.1. I've indicated center as O and the end points of the diameter as P and Q. I've taken this line x1 y1 and x2 y2. From the theorem 10.1, x1 P Q is 90 degrees. Again similarly we will have all the other three angles also as 90 degrees. This angle and this angle will also be 90 degrees. x1 PQ is 90 degrees and y2 QP is 90 degrees. Since both are 90 degrees, right hand side of the equations 1 and 2 is same, therefore left hand side will also be same. I'm equating these two and say proved that these two lines are parallel to each other.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment. And make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, axe. The right group and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacations shorter, the bucket list bigger, the night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
We are solving questions from exercise 10.2. The next question I will solve is question number 6. Question number 6. The length of the tangent from a point A at a distance 5 centimeters. I am reading out the question for you guys. Length of the tangent from point A, if this is the tangent and this is the point, length of this tangent from point A is 5 centimeters. At a distance of 5 centimeters from the center. Length of the tangent from point A at distance 5 centimeters. Length of the tangent I'll write out the question for you guys. The length of the tangent, length of a tangent from a point A at a distance 5 centimeters. At distance 5 centimeters from the center of the circle. From the center of circle. From the center of circle is 4 centimeters. Find the radius of the circle. Find the radius. The length of a tangent from point A at a distance 5 centimeters. If this is my point A, and length of the tangent, now this length of the tangent is actually 4 centimeters. That's what it means. So 4 centimeters at a distance of 5 centimeters from center of the circle. Now this tangent is at 5 centimeters, that is 5 centimeters from center, say O. And you have to find out the radius. Join these 2 points and indicate this by letter O, P. Now you have to find out radius OP. Let me indicate by symbol R for radius. Now from theorem 10.1, this forms right angles at right angles 90 degrees. That is, tangent meeting the line or the radius is at right angles. Writing the Pythagoras theorem again here, OA square is equal to that is hypotenuse square is equal to OP square plus PS square. OA square is 5 square, OP square is R square, this is R square, and PS square is 4 square. 5 square is 25, R square plus 16, so it is 25 minus 16 is equal to R square, so R square is equal to 9. Therefore R is equal to, when I remove the square root or when I remove the square, I'll have plus or minus 3 here, but you cannot have a negative sign for the length, so therefore I say R is equal to 3 centimeters is the radius of the circle. Pretty simple question based on Pythagoras theorem, but understanding of the statement was a little bit trickier. The length of the tangent from a point A, that is length of this tangent from a point A from the center of the circle at 5 centimeters. From the center of the circle at 5 centimeters is 4 centimeters. And find out the radius. From the theorem 10.1 you have these right angles, that is OPA is 90 degrees. Apply Pythagoras theorem and substitute the values to get R. You get 3 centimeter, and you cannot take a negative sign here. You just neglect it or ignore it because length cannot be negative.